Howdy y'all, I'm Joe Hughes, and I'm here to give a presentation entitled From VMs to Kubernetes. This is going to be introductory concepts and live deployments. We've got a bit.ly link here at the bottom. If you need to actually deploy a Kubernetes cluster, that's not going to be something we're going to cover in this presentation, just because that's going to take a little bit of time. We've got some blog posts available for this, whether you're trying to run this on, bare metal versus VMs versus TKG inside of an environment, or even like Raspberry Pis, right? We're going to have plenty of links available to get you guys up and running with an actual Kubernetes cluster, and then we can get started. So, howdy. If you missed it before, I'm Joe Hughes. I'm here because I'm a VMUG leader and I love to get people engaged and learning. You can find me at jhughes on Twitter, or you can find me at fullstackgeek.net because nobody will ever spell my name correctly. Go to bit.ly/FromVMs to Kubernetes again to find the code and blog posts on how to get started with an actual Kubernetes cluster itself. So, why learn Kubernetes, right? I found this quote a couple years ago when I was first getting into playing around with Kubernetes, and I thought it was absolutely fantastic. It's like landing on Pluto when people are still trying to figure out Mars or other tools properly, right? This is a platform that's all about orchestration. It's all about, having tons of power by having a platform that manages things for you that we used to have to do in the past. So rather than you writing a bunch of code or health checks or dealing with all sorts of things that are not relevant to the application you're actually trying to get running, all of that stuff goes away, right? This is just something really important for us to understand as we're getting into Kubernetes, especially for vSphere admins, right? So let's level set some expectations, right? This is going to be basic concepts and seeing some things in a Kubernetes lab environment to hopefully understand better all of the components and how these pieces play together, right? Will this session make anyone an expert? Absolutely not. But it should help you to learn some terms and see the basics in actions, right? And it will give you another step in your learning journey. So, Kubernetes or K8s, right? What is K8s? K8s just represents, like the 8 there represents the 8 letters between K and S in Kubernetes, right? So Kubernetes or K8s, one and the same. This is a Greek for pilot or helmsman of a ship, right? That's what it's intended to mean. Basically, it's somebody who's like in control of this journey, right? Taking care of getting things around. This was a project spun out from Google as an open source orchestration platform. Think about managing containers and think about doing that at Google scale, right? That was where this came from. It originally started as the Borg platform internally, then they open sourced it, made it available to folks, and there have been thousands of other contributors and hundreds of hours that have been devoted into open source contributions back to this, just from lots of other people running it in production and scaling out workloads and putting a lot of that logic back into the platform itself. Kubernetes is designed to be a loosely coupled collection of components that are centered around deploying, maintaining, and scaling workloads, right? Loosely coupled meaning that all of these components have little knowledge of each other and they function independently, right? That makes them all easy to replace or to integrate with other systems. Kubernetes, it's meant to orchestrate cloud-native microservices applications, right? We'll get into the terms of that. It's not just buzzword bingo here. But Kubernetes is also built with the concepts of declarative state for describing your environment and having control loops to make it happen, right? Why do we need this, right? So let's step back and see how our environments are changing. Right, so a quick note on VMs versus containers, right? So what we had before was, VMs here, and this entire thing was our VM that we were dealing with, right? We had a guest operating system, we had binaries and libraries we were dealing with, we had, an application that sat on top of that. This is all after we have our infrastructure up and running and our hypervisor, right? Infrastructure is a ton, right? This is all of our network, our storage, our hosts themselves. Then we have the hypervisor to manage on top of that. And then we have every one of these instances of a virtual machine, right? Which is, back in the day was golden templates and imaging all of these things, keeping them patched and updated. And then once you've instantiated an actual VM out of this guest operating system template, now it's a full guest that you've got to manage the lifecycle of, right? You've got to deal with all those binaries and libraries and security updates and patching and the application patches on top of that. And if you ran into an instance where you needed different binaries and libraries, either you were managing, different directories and different symbolic links all over the place, or you were having to stamp out entire virtual machines to deal with having just another application that needs a different version of some binary or library on top of it, right? Now let's move over to the container space, right? So what we're talking about over here is having a binary and a library and application as we had before, right? This becomes our container. But this is living on top of our infrastructure and now our entire operating system, which have now just been kind of obfuscated, right? We have another process that lives on top of this, which is our container runtime engine. In this instance, we're talking about Docker. Kubernetes has actually deprecated Docker going forward, in a future version, they're going to be getting rid of Docker as the container runtime engine. It's going to go to Containerd. But really what the meaning of all this is that we have infrastructure, we have an operating system, we have a process that lives on top of that that's actually dealing with running all of our containers, right? So the container itself can share everything up through the operating system level. So it's got the full kernel there available to it, right? You only have to load the binaries and libraries in the application. That's the actual workload that you want to deal with and you want to manage at that level. And that's what we're shipping around now. So the container benefits, right, are going to be things like process and file system isolation, resource limits. They're super lightweight. They're very portable. We can do all of this by leveraging namespaces and C groups, some underlying stuff within Linux. Not talking about Windows containers here for this one. But we have now reduced resource requirements, right? Because there's no operating system per application, right? This is application management focused, not VM and operating system focused. So now let's move into what things we're actually dealing with nowadays, right? Microservices and cloud native, right? So a microservices application, right? This is where we're talking about not shipping around full operating systems anymore. This microservices application is made up of lots of small specialized parts that each do their own thing, and they're all loosely coupled to make a useful application. But each of these components can be independently updated and have new functionality added to it without it being the old monolithic applications where an entire guest OS might need to be updated, and the libraries, and then an application, and it might take months and months and months to develop this thing and put it all together and test it and ship it, right? And as we move to cloud native apps, right, these should all be built with having consistent development and automated management in mind, right? They should be able to scale. Let's scale up and scale down. These things should be self-healing. If they're not responsive, we should be able to put in another instance of this application and it shouldn't cause us problems. We should be able to do things like zero downtime rolling updates, right? You want to roll out a new version of an application. We have rules of how that can actually be managed with containers inside of Kubernetes, but we can essentially just roll a new version of an application without ever causing downtime to the service. And these are built to run anywhere on Kubernetes, right? Whether you're running this on bare metal, whether you're running this inside of virtual machines, whether you're running this inside of TKG, or a cloud-hosted infrastructure, anywhere that you're running a conformant Kubernetes cluster, you can ship and run these apps just anywhere, right? That's some of the power of Kubernetes. So, time for takeoff, right? We're going to go and get to the terminology, understand all the components that happen in a cluster, and then for our workloads, and then we're going to get to some actual demos, right? So, what a cluster. I love this image. This actually comes straight out of the Kubernetes documentation for the components of a Kubernetes cluster. So really here, we're talking about a dividing line right here, right, between our master and our worker nodes, right? So this control plane is made up of master nodes. These should exclusively run the control plane and not user applications, right? This may be fine in a lab with few resources where you can run workloads on them, but in production, don't do it, right? You want to have more than one master for HA, and again, it might be fine for a lab to only have a single master. That's not a problem. But masters run the API server, right? So we're going to have our API server here. We're going to have our store, which is going to be etcd. We're going to have our scheduler. We're going to have our control manager and our cloud control manager. So the control plane breakdown is going to be that the API server is the only part of Kubernetes that you actually talk to, right? That's how all of these nodes are getting in and actually communicating to Kubernetes itself. This is going to be the same thing whether you're using any GUI, CLI, or even coding against the API itself. It all goes back to the API, and that is the only thing that's going to respond back to requests for you. The scheduler that we have down here actually chooses which nodes that you run user applications on, right? This etcd store, it's a distributed database where the cluster state and the applications themselves, the definitions are stored, right? The control manager is running processes like our node controllers and job controllers and endpoints, and then handling service tokens and service accounts and tokens. Then the last component that we have here is the cloud manager, right? This is going to embed cloud-specific knowledge, and it allows Kubernetes to link to a cloud provider API for accessing things like cloud storage or load balancers, right? One last note, if you're using a hosted Kubernetes service, they're going to be responsible for this entire control plane over here on the left. You just run your worker nodes and your applications over here on the right, plus, pay the bill. So let's get into our application side of the things for worker nodes. So what we're talking about in this node here, this is where our applications themselves are actually going to run, right? So all of our nodes are going to run a kubelet, and they're going to run a kube proxy. And they're going to have an underlying container runtime, which is not shown here, right? In this instance, it might be Docker, it might be containerd. This is just what's going to live on your operating system level. It's going to actually run the containers itself. The kubelet that we're talking about here is the main Kubernetes agent, right? It will join a node to a cluster. It'll make sure that containers are running within a pod, and it will communicate with the control plane. This kube proxy is the network proxy that runs on each node, and it makes up part of the Kubernetes service concept that we'll cover in a little bit. And then the container runtime itself, which is not even shown here in their documentation, is the software that actually handles the running of the container itself, right? Also to note is there's cluster DNS, right? There's going to be a DNS server that lives on every one of these nodes even, which is going to serve records for Kubernetes services, as all containers within Kubernetes automatically include that cluster DNS server for their lookups. So they can easily find services that are registered within the cluster itself, and we'll cover that in just a second. Pods labels, deployment services. Oh my, right? So what about containers, right? Nope. We're actually talking pods. We'll cover this when we get into the code of this, but the smallest workload that you're going to be managing within Kubernetes itself is actually going to be a pod. It's just a container image with a little bit of wrapper, description around it, right? Labels are something that are actually important here, right? Think of this like vSphere tags, right? These are going to be associations that we actually have where a particular pod gets labeled as part of a deployment, which gets labeled as part of a particular project and things like that. And these labels can be carried across multiple different levels of components inside of Kubernetes so that you can easily identify and figure out what it is you're trying to talk about with just tagging something and basically using that label elsewhere. So deployments are actually the what and the how of things run, right? It's what image are we trying to run? How many of these things are we trying to do it? What is it supposed to look like? What services is it supposed to tie to? And then services themselves, right? This is how you expose applications from Kubernetes outside of the cluster and make it available. So let's see this in a picture and then we'll dig into code and demos, right? So different view that we've got here for looking at things. So inside of our Kubernetes cluster, like up here, we're talking about the Kubernetes Master, right? That's going to be the master node that's going to handle all of our control plane instances. Over on the left side here, we're going to have a node. This is going to be where our applications are actually going to run. So in this instance, we've got a pod on the left, we've got a pod on the right, and basically these pods are just the simple wrapper for a container, right? Each of these pods that are shown here has the label, that's the little tag looking icon that's there, and then some of these actually have a service. Between the node on the left and the node on the right, there are pods that both have red labels that are going up to the single red labeled service that's on the screen here. That's showing that this is a service that is distributed with pods running on multiple nodes. If you hit this service endpoint, it's basically going to just kind of load balance you to wherever it is that you're going to try and hit a running instance of that pod, whatever node it is, right? Kubernetes will just balance that for you and you hit the service endpoint and you're just going to get to one instance of that. Same thing with the pod on the left that has that blue labeled service. Here there's just a single instance of a pod, but it has a service associated with it so that it can be exposed even if it's just one instance of that pod that's running within your Kubernetes cluster. So I know some of these are fuzzy concepts at this point still, but basically, right, you're going to have a pod, it's going to have labels that make it easy for you to identify when you want to work with this thing and make more of them or deploy it elsewhere or give it a service or make it accessible to a load balancer and things like this, right? So pods basically are containers with a little wrapper. Labels are how you identify things. Service is going to be how you're going to expose these outside of the Kubernetes cluster. With that, it's demo time and let's get started. Okay, y'all, we're back and we are going to get started on our demo. So for step one of this, we're going to take a look at a simple web app that we've got here that's going to be running first locally in Docker, and then we're going to run it in Kubernetes. We just want to take a look to see what this app looks like ahead of time. So this is a simple Node.js app, right? Just named it, Container Web Demo. Basically a license that, there be dragons, there's all kinds of stuff. I strictly ripped and replaced a bunch of this code from other demos in the past to have something simple to look at. The app.js basically just shows us here that all we're doing is loading up this home VUG page in the views folder here. Just, simple container demo. All this thing really is a page that's going to show us, like a hello message, glad to see you, and have a couple of buttons with URLs in it. And then the Docker file shows us that there's, really nothing to this. Like it, current slim image that it comes from, for the maintainer, it's copying code over to a directory, running an npm install, exposing port 8080, and then just, starting it up, changing to the source directory, and then running, node app.js. So let's go ahead and get this up in Docker and take a look at what we've got here for this thing. Again, we just want to show what the web app looks like. So this is going to be Docker desktop on Windows on my box here locally, getting this thing up and running. So we have this running. We will refresh. I've got this running localhost port 49,000, right? Just a simple hello from Southwest Regional VMUG Virtual UserCon. First of all, we're glad to see you. Hope everybody's enjoying some Kubernetes goodness. But, simple web app. We've got it up and running. That's what it looks like in Docker. So now I'm going to go ahead and list out and stop this Docker container, just because I hate having stuff running in the background. Whoops, if Joe can copy and paste correctly, because demos are going to always go badly. Let's go ahead and get that stopped. So we've seen that the web app will load just as a container quickly and easily on this box here locally on Docker. So we're going to go ahead and flip over to my Kubernetes cluster that I've got here. This is actually going to be running inside of TKG in my lab environment. And it's actually, let me pull this up real quick. We can take a look at my lab real quick just so you guys can see what everything looks like here. it's not super heavy on resources, right? I've got a TKG management cluster that lives here. I've got a TKG workload cluster that lives here. And really these are, simple, easy VMs. They're 2 CPU, 2 gigs of memory, 20 gigs for the hard disk because I brought these up in the dev plan, right? So single master node, single worker node, one for the management cluster, one for the workload cluster as well. So just if nobody's ever played with TKG, it's really easy to do. Again, we've got the links to get this up and running inside of that bit.ly link that's shared in the slides. So let's go ahead and get back in here, and from the Kubernetes side, we will go ahead and see what we actually have in here. So I'm going to go ahead and run a kubectl command. We're going to do config and get contexts, and I will apologize now, this is going to look a little bit goofy on the screen. Basically, we have a context for our management cluster and we have a context for our workload cluster, right? So the current context that I'm using right now is this TKG workload admin. So let's do a kubectl get nodes and see what we've got. So I have my single master node, I've got my single worker node, both ready. No roles on that worker node, right? That's what we want to see, right? So we want our user apps to not be running anything for our workloads themselves. So we're now going to do a kubectl get pods, right? And look, we have no resources in the default namespace, right? There's no pods already running, just showing everybody it's clean. There's nothing in here. So for the pod, this is kind of where I was telling you during the slides that, the pod is going to be the definition of a container with a little bit of wrapper around it, right? So we're going to name a container inside of this spec bit of the code here. Container is going to get a name. It's going to get an image, which is just Joe Hughes. I have an image or a Docker image called vmug app, and we're running version 1.01. Right, same exact thing that I was running inside of my Docker instance here locally on the box. We're exposing port 8080 just because that's what's exposed on that Node.js app. And the metadata for this is just that we're giving it a name of vmug first pod will actually be the pod name, and then the project is vmug demo, right? This is one of those labels that I was mentioning in the slides, which are ways to associate things, right? This label, this project label, will be carried kind of throughout all of these config files, and we'll bring it up as we get into some other stuff. So to bring up our first node, we're going to do kubectl apply --f, and we're going to do our pod YAML file. Our first pod is created. So now we do our kubectl get pods again. Huzzah, look at this, congratulations, right? We are now running our first app inside of Kubernetes. So if we want to get some details about it, we can run kubectl describe pod, and we said this was vmug first pod. So we see some description about this, right? And it's a ton of information, right? It's a little bit hard to consume on the screen here. But we have a name, it's in our default namespace that shows us which node it's running on. It's got a label of a project equals vmug demo, right? So it's easy for us to associate this, all throughout all of our config files. We've got an IP address, right? This is an internal IP address within the Kubernetes cluster itself. But it shows us, is it ready? Yes, state is running, right? The port that it's getting exposed on is 8080 for TCP, right? Restart count of 0. So lots of good information, information about the conditions of what's going on with this pod and everything that's here. And then all the events that actually happened for it, which is basically that, we scheduled it, it pulled the image, it created it, it started it. Very simple, right? But we now have our first app running in Kubernetes. But we can't actually get to this thing, right? Because it's on that internal IP address that's in here for just that particular node. So if we were going to be running this inside of, say, Kubernetes and Docker, right, where this was going to be local and we were actually on a box and wanted to expose this locally, we could put this on a node port. So that's what we have here in this svc vmug local file. That's going to be, trying to expose this service on a node port where we can say, the node port is going to be 32,000. That's going to direct it to a target port of 8080 on this thing. And the selector that we have here is, again, this project label for vmug-demo. So we can actually go through and apply this here. So kubectl apply --f. We're doing svc vmug local. We have this applied. Now if we run kubectl get service, we can actually see that we have a service that is defined for this, right? The name for the service, svc-vmug local. It's a spec of assigning a node port, basically, from 32,000 on the node to 8080 on the pod itself, right? So that's what we have here. We have the name of our service, we have our node port, we have the cluster IP, we have the port, but we have no external IP, so that doesn't really help us a lot. So what we're going to do here is I'm going to show you what we would normally do if we were running this in, say, a cloud instance, right? This is where we were saying that by extending through those cloud controllers and things like that, we have the capabilities of just plugging into other functionality that might exist. In this instance, we're going to take advantage of what would be a load balancer, right? Inside of my Kubernetes cluster, I cheated and actually ran ahead of time that I've got Meta LB running, right? So I have an IP range where I can share inside of my production network for this load balancer that, these pods can get presented through that load balancer. So what I'm going to go ahead and do here is I'm going to go ahead and delete the service kubectl delete SVC for my SVC vmug local. So we're going to delete that instance. We're going to go ahead and run the YAML file for our load balancer. What did we call this? SVC cloud YAML. Okay, so now that we've done that, let's do our get service again. So we have kubectl get service, and ruh-roh, something didn't work right here. Oh no, I'm sorry, I was just totally missing the name of the service here. I renamed the service to cloud-lb for service. I was looking at the default Kubernetes service here. Sorry guys, it's late and I'm in the middle of moving, so it's been kind of a long day. So the new service we have here is cloud-lb. So we have a load balancer. The cluster IP is still here that it's being presented through, but now we actually have an external IP, right, of this 192.168.82.240. So if I go ahead and copy this and get back into my web browser, I believe I had an instance of this already open, but let's go ahead and browse to it new. And look, we can see we now have our web app that's open. So this is a load balanced IP that's getting into my Kubernetes cluster that's actually running inside of my vSphere environment, right? So all this is getting routed through my actual network and everything here. And it's now exposed outside of the cluster through a load balancer IP. So local instance here, right? Kubernetes instance here, just so everybody can see they are actually different IPs. So now that we've got this, we're going to go ahead and clean everything up a little bit. So let's do kubectl delete service, and we want to delete our cloud LB, and then we're going to do a kubectl delete pod for vmug first pod, and we're going to wait for that to get deleted and return back to the command line here, and we will proceed with our next demo. Okay, while we're waiting for that, we'll go ahead and start giving a description of our deployments, which is going to be the next thing we're going to look at. So deployment's going to require a deployment object and a deployment controller, right? So the deployment object is going to be this deployment YAML file that we have here. The deployment controller itself is just a process that lives inside of the control plane, right? It's monitoring the cluster, and it's making sure that the deployment that we've defined here is actually running as this definition file states for it, or as the definition that we've modified at the command line, as I'll show you, is actually the true statements for it. Right, so right now, let's do kubectl get pods to just show we have no pods here. Let's go ahead and clear this up a little bit. So kubectl get pods, nothing. Kubectl get deployments, and we have nothing here, right? So we're going to go ahead and apply our deployment. It's going to be a name of vmug deploy, right? So our spec for it says that we're going to run 5 replicas, which is 5 versions of this pod. Still using the project label, right, for vmug demo. So the template is that project, which links it back to our original pod that we had, right? So that's going to give us this container of vmug container, always pull the image, expose the port on 8080, and then our image will be this Joe Hughes vmug app version 1.01, right? So using our label for the vmug demo here to match our project to the replica set, just so this, same project for the template and everything gets applied all the way through. So let's do a kubectl apply -f and our deploy YAML. So now we've got this. So now if we run our get deployments again, we have 4 out of 5 that are already getting deployed. So if we look at our get pods, we can see we've actually got 5 pods that are already running. Again, this is a very, very simple web app, so obviously this is quick to deploy. We're going to go ahead and show what happens though when we manually delete a pod. This is going to show as if an application, one of these pod replicas was suddenly not working, what would happen with Kubernetes just kind of fixing this for us because it determined that it was not healthy. We're going to do a delete pod. We're going to go ahead and define this third one here. And let's say this is the vmug deploy ending in Q29BS. So I'm going to go ahead and nuke that. and get back in here to get pods. So we can see that we are terminating this one, and as soon as this one became unhealthy, we deployed another iteration of it, right? So before we had KQ and then K2 and P7 as our first two instances of this pod. We now have K2 and K4. So when it detected that this version of the pod, this replica, was not working, it went ahead and spun up this one because we had it defined that we want 5 replicas running, right? So Kubernetes just caught this with its health checks through the control cycles on everything here and just nuked it, right? It said this one was not working. It's going to go ahead and wipe it and clean it up on the back end, and it's going to go ahead and deploy a new version or a new replica of this pod. If you're running this stuff inside an environment where there are node pools that are implemented, a failed node can also be replaced, but that's logic that's built into node pools or like the infrastructure or the cloud where the Kubernetes cluster is running, right? This is not a deployment feature. I just want to call that out because I had somebody that had asked me about that even just earlier today with there being issues with a node rather than a pod. Okay, so that was a little bit on just some self-healing, right? So the next thing we want to look at is scaling, right? So we're going to go ahead and do our kubectl for git deployment. Oops. For vmug deploy. So now what we want to do is go ahead and increase this to 8 replicas that are running. We will go ahead and save this file. I'm going to go ahead and verify that this actually came across correctly. Okay, cool. So it did update to 8 replicas that we have here in our file versus 5 that it was before. So we're going to run kubectl apply --f deploy, and now we're going to run our git deployment of vmug-deploy again, and we should see now that we have 8 of 8 because we updated our deployment YAML file, right? We redefined this thing, we reapplied this configuration that updated the deployment to 8 replicas rather than 5. So it's already there, it's already running these things. If we do kubectl get pods, because these things are so small and so quick to spin up, you see that they're already here, right? So we have this instance of a pod here, which was the replacement for the one that I manually deleted a pod and it spun up. That's why we have some up at 3 minutes and 9 seconds, one that was about a minute later, and now we have 3 new iterations of this pod that are up at 25 seconds, right? That was us modifying that deployment to say we now want 8 versions of this instead of 5. So now we're going to manually scale this down with the CLI. So we're going to do kubectl scale, if I can type correctly, replicas 6 for deployment /vmug-deploy. Okay, so we should see that this deployment is now scaled rather than configured, right? Because we didn't apply a YAML file for configuration. We scaled it with this. So let's go ahead and do our git deployment for vmug deploy, and we should see now the number of pods, the number of replicas that we have is 6. And if we do kubectl get pods, if I'm quick enough, we will see that we're actually terminating 2 of these because we're trying to get down to that count of 6. So those are going to take a little while to actually terminate because they take longer to tear down than they do to deploy. One thing to be cautious of though, like with this, as you can see, if we do this at the CLI where we've scaled this thing, I've defined in the command line at this instant that I want 6 replicas of this node, of this pod here. The problem is my deployment YAML file still says 8. So if I even did something like if we updated the app and wanted to update a new version of the image and roll that into production, if we wanted to rename the containers or apply a new project label to this thing, or even if I changed the actual web app and I exposed a different port on the container, if I changed it to 8081 and I simply came in on my deployment YAML file and modified the container port here for 8081 instead of 8080, when I apply this deployment YAML file, it's going to put back in this original replicas of 8 that I modified it to when we scaled up our cluster. So this is defined, right, and this is going to get something that's going to be configured to the actual deployment as it was here when we applied the file, right, as opposed to here where we just told it kubectl scale at the command line. My point is really just, be careful with this, right? Stick to one method for updates, right? Either do everything in the CLI or do it in the YAML. Best practice, and honestly pro tip, just stick to the YAML. It's easier to see these things, to know what the definition is, and keep this updated properly in version control. So we're going to go ahead and decrease this to 5 again, right? Save the file. I'm going to go ahead and do a cat on my deployment just to make sure it's there again, and we will do another apply of my deploy YAML file. And now if I come back and get my pods, we'll see that we're terminating, and if I get my deployment for vmug deploy, we are back to a definition of 5, and this is now matching back to what I actually have in the deployment YAML file, right? So now let's do one last bit for a rolling upgrade. So what we're going to do here is add a couple of lines to our deployment file. So right after my project, I'm going to insert some things in here, and let me make sure that I have the spacing on this correctly. And we're going to explain what we have in here. So for this, what we're doing is defining a couple of things, right? So the minimum ready seconds here is just going to be the amount of time that Kubernetes will wait after updating each replica. Really, in this instance, it's going to be like a delete and a replace, right? This strategy definition in this type just tells us that it's a type of rolling update, right? Which means it's going to be updating without taking services offline. For the rolling update definition, this max unavailable is going to be 0, and that means, you know, this can either be a number or a percentage of how many pods are allowed to be unavailable for this rolling update. For this, we've defined 0, and we've defined a max surge. This max surge number is how many pods that can be created over the desired number defined in this deployment, right? This replicas of 5. This can, again, be a number or percentage. What this is saying with max unavailable 0 and max surge of 1, we're allowing it to add 1 pod to our deployment because we're saying 0 can be unavailable. So it's going to add 1 pod with the new version, and once one of these is up, it's going to take one of the other old versions down. So the other thing we're going to do with this is I'm going to go ahead and change the version of my image to 1.1. Okay, so we're going to save this. I'm going to, again, just cat my deploy YAML file to make sure all this came through. Okay, spacing and everything looks correct. If you haven't done much with YAML, be careful, because it is terrible if you are not great with spacing. I suggest getting an IDE that will show you blank spaces. So we're going to do kubectl apply space-f deploy YAML. Okay, so that is now configured, and we are now going to do a kubectl rollout status deployment demo-deploy. So while we're waiting for this, right, this is telling us now that our deployment is waiting for it to finish, right? One of the replicas has been updated. Now 2 of the new replicas has been updated. If I come back and refresh this, we'll see that eventually this page is going to go from a hello, and if I keep refreshing, we're going to hit a different instance of the pod, or we'll just catch it once it finally updates everything. Okay. Yep, I forgot to put my load balancer back in place. So what we've now done with the load balancer back in place and having this accessible outside of the cluster again, is we've now flipped over to the new version of the image, which basically has just changed this from our original hello message to goodbye, right? Just wanted to finish this up by saying to everybody, I'm glad y'all came out, and I really hope everybody learned a little bit. Let's go back for our final slides and a little bit of wrap up. Okay, thanks y'all for coming out. I really hope everybody enjoyed this. Hopefully you got a little bit out of the understanding with some of the terms and seeing some, you know, images and documentation to kind of understand what bits we're talking about, you know, as we're flipping from VMs to containers and now learning Kubernetes for all the orchestration and things like that. You know, honestly, get a couple of pods, play with some things. Check out the link here again. I want to kind of hammer it home for the resources, right? This will help you to get a Kubernetes cluster up and running, whether you want to do, you know, bare metal or VMs or TKG or, you know, even the Raspberry Pis and things like that. There's tons of resources and stuff that's out here. So, you know, blog posts, things that have been curated, some good videos and everything that are here will all be linked right here for bit.ly from VMs to Kubernetes, right? Just screenshot this thing. If you have any questions, you know, find me. I'm at jhughes on Twitter, or joe@fullstackgeek.net if anybody actually just wants to take this thing to email. And we'll get you guys up and running, right? We'll get you Kubernetes cluster. We'll get you some apps deployed. I have some links also under this from VMs to Kubernetes that once you're trying to just play around, right? It's some stuff with load balancers. It's some pre-formatted apps. Some of the stuff in the Bitnami catalog. Some great demos that William Lamb linked to for things like, you know, playing Doom in Kubernetes, right? It's absolutely fantastic. So again, thank you all for coming out. I hope everybody learned something. And if you guys have any questions, feel free to reach out and hit me up. All right. Thanks. Y'all have a good one. Bye.